So we're going to look at basic exponential equations, and they follow this rule. If b to the x equals b to the y, so b to the x power equals b to the y power, then x would equal y. Which when we do an example or two, hopefully it'll make sense. So b is a real number, and it is greater than 0 and not 1. Same as when we defined exponential functions. So kind of similarly, to solve an exponential equation, b would have to be a real number greater than 0 and not equal to 1. So let's say, for example, we want to solve the exponential equation 5 to the x power equals 125. Okay, so what we're trying to do is try to get the base to be the same thing, b to be the same thing. So if we look at this, looking at the 125, if we make 125 5 to some power, what would it be? It would be 5 to the third power. 5 to the third power is 125. Okay, if you have the exponent chart, if you did an exponent chart way at the beginning of class, possibly. So if you create an exponent chart, it would be definitely handy to have at this point. So you'd look for that 125, 5 to the third power. So if you look at this, I mean, if you have 5 to the x power and 5 to the third power, I mean, the only way this is going to work out if x is 3. Okay, so the 5s, it's kind of like the 5s just drop out once they're the same. Once the bases are the same, they kind of just drop out, and you're left with whatever the exponents are, which is what the definition says. Which, if you go back and check it, check the equation, you're really just plugging in 3 for x. Is 5 to the third power 125? Yes, that is true. Okay, so that's kind of a pretty basic one. Now, how about the next one a little harder? 4 to the x power equals 8. We're going to solve this. Solve 4 to the x power equals 8. So now, if I look at this, I mean, I can't make 8 4 to any power. Or I could, but it'd be a little too complicated. But instead, think about, well, what could I do to make them have the same base? Well, 4 is 2 squared. So I'm going to replace 4 with 2 squared. And 8 is 2 to the third power. Now, you know, this is kind of going back to our exponent rules. If you have a power to a power, the power rule, you multiply the exponents together. So this is the same as saying 2 to the 2x power. Now that I have the same base, the 2's as the base drop out, and I'm left with the exponents as my equation, 2x equals 3. And then I just solve from here. So in this case, divide both sides by 2. So x equals 3 halves. Or if you want to change it to 1 1/2 or 1.5, whatever form you want to write it in. Okay, let's do one more. Let's solve 9 to the x minus 1 power equals 27 to the x power. 9 to the x minus 1 power equals 27 to the x power. So I'm looking at my 9 and 27, and you should be thinking, okay, 3. I can use my base as 3. 9 is 3 squared. And 27 is 3 to the third power. Again, exponent to an exponent, you would multiply them. So this is the same as 3 to the 2 times x minus 1 power. I'm going to have to use parentheses there because the 2 needs to be multiplied in both parts. And then this equals 3 to the 3x power. Now that I have the same base, it looks, you know, kind of like my b to the x equals b to the y format. I drop my 3's, and I'm now just left with the equation 2 times x minus 1 equals 3x. Now it's just a regular equation. 2x minus 2 equals 3x. Subtract 2x from both sides. Negative 2 equals x. And I'm done. So x equals negative 2. This might be a good one to check. Let's go back up and check. Is x negative 2? Let me check over to, we'll bring it down. So I have 9 to the x minus 1 is 9 to the x minus 1 equal to 27 to the x. Well, 9 to the negative 3, is that the same as 27 to the negative 2? And, well, maybe I should have checked this one. 1 over 9 to the third power, is that the same as 1 over 27 squared? And I do not have my calculator with me. What is 9 times 9 times 9? 81 times 9, 729. So this is 1 over 729. Should know that. 27 times 27 is 729. So it checks out.